In the previous video, we talked about embedded system, alright, and we talked about the 5 approaches. Now we're gonna go into more focus into microcontrollers, which is often being used in reality right now. This is chapter 2, microcontrollers, and I will go in a chop fast way manner also. Microcontrollers has no operating system. What do I mean by operating system? The computer, if I type A, alright, there will be a lot of programs that is going on, inbuilt programs. Like if the user type A, then some logic 0, 1 occur, and then 1 occur, it will send to a certain system and say, okay, this person type A, and then it will display in the screen A. So this is inbuilt program. It has operating system, meaning these inbuilt programs are the operating systems to operate a certain function and compute the task for you. However, it takes a lot of space because you have a lot of programs within it. So therefore, in microcontrollers, we do not have this thing anymore, right? We do not have this because there's no enough good enough data space for it to go, and therefore you need to own self program it for your certain function that you want. Key understandings for this is that the program coding is required for operating system, alright, and therefore in microcontrollers you need, instead of an operating system, you're actually coding your own operating system, for example. In other words, now since we know that microcontrollers is not an operating system, then what is these components that is within this microcontrollers? The components are ALU. ALU is, what is it? Arithmetic logic unit. To perform 1 plus 1, 2 plus 2, 2 times 2, 3 divided by 1. It helps you to compute arithmetic, very simple functions. These are the things that build up other codes, other very more complex codes, I would say. So therefore it's necessary. Next up, memory for program, ROM, memory for data, RAM. What are they? Memory are simply address of a data that is often operating in terms of two things: address of the data and the data itself. So you give the address of the data, like maybe Jurong East 21. There's Papaya. So Jurong East Street 21 is the address, and the papaya itself is the data. For example, okay. Type of memory: volatile, non-volatile, RAM, ROM. What are they? Volatile means that when the power is gone, data is gone, and it's often used to process data to perform certain tasks, meaning you have data A, data B. Alright, so RAM itself is taking data A and transfer to data B by operating by using maybe data C. So data C takes in data A, and then they extract data A and then bring it to data B. So RAM is simply in this form, volatile. Once you take it, you just use it for once and then that's it, gone. Or perhaps you use it for once, twice, whatever, but once the power is gone, data is gone. That's all. Miscellaneous purposes. Non-volatile. Alright, non-volatile is simply like this page over here. If you have a data, you have a data, you have a data. It's all stored. And all stored means that it's talking about the hard disk, for example. And can be erased or write. Alright, in this case it's EEPROM, meaning this is ROM. Last time the ROM, it's RO means read only. Last time it's read only, but now EEP means it can be erasable. Something like that, okay? So for non-volatile is for program, volatile is for data, and this is why it's written over here: memory for program, ROM, memory for data, RAM. Okay, done. This component, communications with the outside world. You need an interface between digital and analog signals. I think it's not being discussed over here, so never mind. In the future, there will. I forget to continue. Alright, in order to talk about memory, you're going to talk about communication, how the data are being communicated, and they are through buses. Buses are what? Used to transport the address and the data. Address of the data, meaning the memories itself. For example, just now I say that the RAM takes in data from C and then go to A, and then it takes the data from A and then goes to B. Right? These are the activities of a RAM, correct? But how do they go from, and how does the data go? It's through by this bus. This bus is the connection. This line that I'm drawing in red is the buses. It's just a road or a railway track or whatever thing that could travel and allow the transportation of a certain data from one place to another. That's the meaning of that. That is called buses. Just buses. Therefore, what are the types of communication method? This is coming from the communication. Communication means that you're using the bus to communicate with other system. Now, then what type of bus are you using? You're taking aeroplane, train, whatever. For Harvard, there is one bus for one address, one bus for data. Okay? Because memory has in terms of address and data, correct? So therefore one bus for address, one bus for data, nice enough. And then but however internal components is a lot because you have so many things to go with. Now Princeton is on the other hand is one bus but is for both address and data. It's less component but complex in the instruction manner. I suggest you read this page and this page. I'll just go through what thing is that. I have a certain processor over here. So this is the address bus. It takes in a certain memory from the ROM and then go through here. And then it also takes in certain RAM and then go through here. And then it process something like that. I should say in a different way. Alright, if I want a certain data in the ROM, I will have an address that's sent to the RAM. The RAM will gather certain data and go to the ROM and gather certain data also. Or in other words, anyway, they are transporting data and address in two different buses. That's what I want to convey. Therefore, what is this? This is the overall summary. Overall summary what? Program is the one that I've been talking about. Is the ROM. Then this is the RAM. And they are transported through buses, as you can see, red color, data buses. Alright, and address buses in green. We have arithmetic logic unit over here that can help us to calculate 1 plus 1, 2 times 2, because this is a very basic system for us to use in order to create a certain complex stuff. So ALU very important. We need a clock. Just now I never said, but now can say. Clock is to synchronize the system. Maybe 1 second, 2 seconds, you do what, 3 seconds, you do what. I think this is what it means. Or calculate a certain pathway or whatever. Anyway, later on we'll know. Alright, and ROM, an instruction decoder, is to decode the whatever program that it is inside a certain data. So for example, this ROM contains a Chinese language. Instruction decoder will translate Chinese to English, something like that. Input-output ports is to connect your digital world to the analog world. Alright, so therefore you need certain peripherals. So the peripherals will go to timer, watchdog timer, whatever thing. But however, when you're gonna talk with the outside world and the digital world, you need ADC. And then how do you use ADC and how do you connect? Is using USB interfaces. Alright, and things like that. This is the summary of chapter 2.